Okay, so now let's look at arctangent. Okay, so arctangent, we're going to restrict that to a domain where it passes the horizontal line test. Okay, so we know that that has a vertical asymptote here at negative pi over 2 and at pi over 2. And really at any odd multiples of pi over 2, like 3 pi over 2, 5 pi over 2, and so on and so forth. And our graph of tangent looks like this. Okay, so we get one full period here between these vertical asymptotes, and we see that in this period it passes the horizontal line test, right? So we get the entire tangent graph right here, passing the horizontal line test. But if we go even a little bit further, we'll be starting to repeat y values. So this is as big as we could possibly get. So our restricted domain, right, for tangent is, well, it's negative pi over 2 up to pi over 2. So that interval between negative pi over 2 and pi over 2. However, negative pi over 2 is, tangent is undefined at negative pi over 2, hence this vertical asymptote. And tangent of pi over 2 is also undefined. So these are not in the domain, so it's an open interval from negative pi over 2 to pi over 2. So that means when we define our inverse function, tangent inverse of x, which I'm going to call arctangent of x, right? Then our domain, right, will be the range of tangent, which is all real numbers. That's really cool, right? We get all real numbers from the range of tangent. Okay, so that's going to be the domain of arctangent. And then the range of arctangent will be the same as the restricted domain for tangent, which is the open interval from negative pi over 2 to pi over 2. Okay. All right. And so we can do kind of like we started with last time. We could try to find values of arctangent. Like, what is arctangent of negative square root of 3? Right? And so the idea is the same, right? We're going to let theta be equal to arctangent of negative square root of 3. We're going to use our inverse property to say that's the same thing as tangent of theta is equal to negative square root of 3. And then we're going to try to find our thetas where tangent of theta is equal to negative square root of 3. And now, with sine and cosine, it's easy to look at the unit circle, and you're able to tell what angles have cosine of theta equal to this value, what angles have sine of theta equal to this value, because sine of theta is the y value and cosine of theta is the x value. But the tangent of theta, that's not really easily readable off of the unit circle. And that's because tangent of theta is not the x-coordinate or the y-coordinate. It's y divided by x. So you have to compute y divided by x for each one of your angles and see if it simplifies to be negative square root of 3. Okay, so that might be something you want to do ahead of time, right? You know, come into class with it already simplified, y divided by x for each one of your 16 special angles. Okay, and so where does tangent of theta equal to negative square root of 3? Well, that turns out to be the case at theta equals 2 pi over 3 and at theta equals 5 pi over 3. Those are the two angles where that happens. Okay. Now, neither one of these angles is in the range of arctangent. So what can we do? Well, let's just find some coterminal angles and see if that helps. So if I subtract 2 pi from these, because both of these are too big, so I'll try subtracting 2 pi, I'm going to get a negative 4 pi over 3 and a negative pi over 3. Oops. Okay. Now, negative 4 pi over 3 is much too small. It's less than negative pi over 2, so that's not going to work. But negative pi over 3 is just fine. So arctangent of negative square root of 3 is negative pi over 3. Okay. All right. And then we can start looking at some compositions of these, right? So what if I do tangent of arctangent of 7? Okay. Now with arcsine and arccosine, right, we had to be a little bit careful because the thing that we plug into arcsine and arccosine had to be between -1 and +1. The domain of arcsine and arccosine was -1 to +1. But with arctangent, the domain is all real numbers, which means no matter what we plug into arctangent, we're going to get a real number out that we can take tangent of. So this will always be invertible, right? The tangent and arctangent will cancel each other off, and we'll just get whatever argument we put in on the inside. Okay, so that's pretty nice. Okay. But of course, the harder direction is what happens when we reverse the order of arctangent and tangent. So let's see if we can come up with an algorithm for simplifying arctangent of tangent of theta. Okay, algorithm for that. So let's Step 0 is exactly the same. If necessary, find a coterminal angle alpha. Alpha in 0 to 2 pi, right? Okay. And then now, if theta is in quadrant 1, okay, here's what we can do. That angle is already between 0 and pi over 2. So then that means that arctangent of tangent will just cancel off very nicely. So then arctangent of tangent, oh, I said alpha. Oh, sorry, no, if theta is in quadrant 1, good, okay. Arctangent of theta is the same thing as arctangent of tangent of alpha, the coterminal angle between 0 and 2 pi, right? And because this is in quadrant 1, this is already in the right range, right? The range of arctangent, right? The restricted domain of tangent. So they're going to cancel each other off and just get you alpha. Okay, so that's nice. Now, if theta is in quadrant 2 or quadrant 3, here's what we can do. Okay, arctangent of tangent of theta, right? Well, that's the same thing as arctangent of tangent of alpha by coterminality, right? But here's the thing. Tangent has a period of pi. So tangent of alpha is the same thing as tangent of alpha minus pi, okay? So if you're in quadrant 2 or quadrant 3, that means that your alpha is between, well, let's see, pi over 2 and 3 pi over 2, right? To put you in quadrant 2 or quadrant 3. So then alpha minus pi will be between negative pi over 2 and positive pi over 2 then, subtracting pi from all three sides there, right? And so this will be in the right range then, right? And I guess I should be really careful here and say you can't be pi over 2, you can't be 3 pi over 2, right? Because tangent is undefined at those places. But for anything strictly between pi over 2 and 3 pi over 2, we have this, okay? So arctangent and tangent will just cancel off and you'll just get alpha minus pi. That's not bad at all, okay? If theta is in quadrant 4, right? Well, then we have that arctangent of tangent of theta is equal to arctangent of tangent of alpha. But the problem is that your alpha is between 3 pi over 2 and 2 pi, and you need it to be between negative pi over 2 and pi over 2, right? So in order to make that happen, we could just find another coterminal angle. Alpha is too big, so we'll subtract 2 pi from it, okay? And then now this will be between negative pi over 2 and 0, okay? So the arctangent and tangent will cancel off, and we'll get alpha minus 2 pi, okay? Just like we did for arcsine. Okay,